Okay, we are using the formula for NCR to evaluate the following. Now, the good thing is the formula is pretty straightforward. In fact, we actually have it just up here. Well, there it is. So the evaluation for unordered R member sets of the subset S, and don't worry, we will have gone through that in class. So we're just going to use it now. So we're going to go A, and we're going to go I, and we're going to go 8C5. And this is on the calculator, but we're going to do it not on the calculator. So that is going to be 8 factorial over 3 factorial times 5 factorial. Oh, okay. I'm actually going to go the other way around. Sorry. I'm going to go, it doesn't matter because it's commutative, but I'm going to go 5 because that's our R down there. So I want to have our R. And if you have a look, we've got R and then N minus R. So that's why we've got the 3 factorial over there. So I prefer that. All right. So now we're going to roll it out so we can see what this looks like. So you're going to have, and I can roll out. I could do 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. I could do that. But I'm just going to go to that point and go 5 factorial. And the reason I'm going to go to that point is because down here I've got 5 factorial times 3 factorial. And I know that that and that will cancel. So I'm going to be left with 8 times 7 times 6 over 3 factorial. Which means I am going to end up with 56. Whew, there you go. That's that one done. We've got NC3. So that is an interesting one. That's going to end up with NC3. That's going to end up with N factorial over 3 factorial times N minus 3 factorial. Okay. So what we're going to do now is going to roll this out. So we've got N factorial times N minus 1 factorial. Actually, they shouldn't have factorials next time. I should just have N minus 1, N minus 2, N minus 3, and that one should have the factorial over 3 factorial times N minus 3 factorial. And obviously the N minus 3 factorials cancel out. And so you are left with N outside of N minus 1, N minus 2 over 6, which is what 3 factorial is. All right, I'm going to just change colours because it's starting to get a bit hairy in here. So we'll go to question B. It says find 16C5. Choose is sometimes we use. So instead of the C, we call it choose. 16C5, leaving your answer factored into primes. So we're going to find that we'll have primes on there, so we'll worry about that in a sec. What does 16 5 mean? Well, it means 16 factorial over 5 factorial. What have they done? Choose, so it's going to be, 5 equals 5 factorial. I should do actually, 5 factorial times 11 factorial. So then what we've done is gone 16 times 15 times 14 times 13 times 12 times 11 factorial all over. Oops, that's terrible. All over 5 factorial times 11 factorial, which means you've got 16 times 15 times 14 times 13 times 12 all over. Get rid of that. All over 5 factorial, or 1 times 2 times 3 times 4 times 5. So we've done 5 factorial. The reason we've done this is because then I can simplify some stuff. I hope that makes some sort of sense. So if I take the 3 and the 5, am I going to take the 3 and the 5? Or was I going to take the 3 and the 4? No, I'll take the 3 and the 5. 3 and the 5 will give us 15. We'll get rid of that. And the 4 and the 2 gives us 8, so that becomes a 2. So I've simplified those two things, and it gives me 2 times 14 times 13 times 12. Oh, I might move all that up a bit because it's going to be a bit hard to read down there. There we go. So by simplifying out that fraction, or getting rid of the, drag that down a bit. Yeah, simplifying that fraction, I got down to 2 times 14 times 13 times 12. Now, it does say to do it as primes. So if you look at that, you go, okay, well, have I got primes? No, because 12 is not a prime. Well, how else can 12 be written? 12 can be written as 12 could be written as 4 times 3, and that is 2 to the power of 2 times 3. So you'd end up with 2 to the power of 3 times 3 times 14 times 13. But 14 could be written as 7 times 2. So we end up with 2 to the power of 4 times 3 times 7 times 13. Whew, that got a bit messy in there for a sec, didn't it? Oh, no, I don't want to do that. I'll have to leave it like that. So you get 2 to the power of 4 times 3 times 7 times 13, and they're now all prime factors. Cool. All right. Question C. There's a bit of a beast, that bit. Anyway, evaluate the terms on the left-hand side to prove 5C0 plus 5C1 plus 5C2 plus 5C3 plus 5C4 plus 5C5. So what you have to do is then rewrite this in fraction form. So it looks as though it's going to be complicated, but it's not. So we're going to have 5 factorial over 0 factorial times 5 factorial. Then we're going to have 5 factorial over 1 factorial times 4 factorial. I don't know why I'm putting equals. I should be putting plus because that's what's in between them. Then we've got 5 factorial over 2 factorial times 3 factorial plus 5 factorial over 3 factorial times 2 factorial plus 5 factorial over that factorial. What do we got? What do we got? I've forgotten where I'm up to. 4 factorial times 1 factorial plus 5 factorial over 5 factorial times 0 factorial. Okay, so I've done all those. That's one. That's one. So we've got 1. That's 1. So 5 factorial over 4 factorial. If you remember that that's 5 times 4 times 3 times 2 times 1, you're going to end up with 5. This next one, you're going to end up with 10. Then you're going to end up with 10. Then you're going to end up with 5. Then you're going to end up with 1. So what we're left with is 2032 is our final answer, which equals the right-hand side. And that's nice. Okay, if you're not sure of how I got those ones, like in there, just give them a go. Either chuck them on your calculator or do them by hand. They're not that hard.